just for the third. Just the third box is it hasn't been done yet, so I'm going to make sure I got it on there, okay? So the third box is all about this idea called Heron's formula. Yeah, I know. I'm like, oh, that doesn't look right. Yep. Heron's formula. Thank you. Okay, the idea behind Heron's formula, the idea behind this, is that if you were given any three sides of a triangle, any three sides, so we'll just call those sides little a, little b, and little c, because that's what we call them, right? Little a, little b, little c. Then you can find the area. You can find the area. So it used to be the case in geometry where the area was always equal to 1/2 base times height, or we dropped an altitude and figure out law of sines. Well, law of sines doesn't apply to the case when you're given side, 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 so what do? So Heron's formula can be used to solve any triangle if you're given all three sides of the triangle. And here's the formula for it. It looks kind of weird, but it's actually not that bad. So the area is equal to, this is big square root thing here, right? S. I'm going to tell you what S is in just 1 second, right? So S, and then it's going to be S minus each of these. S minus A times S minus B times S minus C. And all of that is under the square root. Okay, so what is the S then? Well, the
S always a constant.
yeah. No. S is this very special number. All it is it's 1/2 of all three sides added up. A plus B plus C. That's it. That's all it is. So this right here is the idea for Heron's formula. So given any three sides, all you do is add up the perimeter. That's what the sides are. Divide by 2. And that's your S value. And that value gets used inside the triangle. So I do have one example I can share with you really quickly. It's pretty straightforward though. When you're given three sides of a triangle, so let me just make this up, okay? How about 10, how about 12, and how about 13? I just made that up, okay? 10, 12, and 13, right? So I have three sides of a triangle, okay? I'm interested in understanding or figuring out the area within that bounded oblique triangle given 10, 12, and 13 as my perimeter. First step that I got to do is I got to figure out this special number S. S is going to be half of all of my sides added up. So 10 and 13 and 12. So let's go ahead and do that. So S is going to be half of 35? 17.5. So half of 35. So S is going to be, I'm just going to call this 35 over 2. Okay? Is that better? Because that's not even, right? Okay, so if S is 35 over 2, I then take this information and I plug it into the Heron's formula. So here's what I get. So it's going to be S, which is 35 over 2, times, and then look what it says, S minus each of the sides, right? So 35 over 2 minus A, which in this case would be 10. And then 35 over 2 minus 12. And then finally, 35 over 2 minus 13. Okay? All you gotta do is plug that in the calculator. You don't have to do it by hand. Okay? As long as you write this part down, you're good for that part, right? So, here we go. Plugging into the calculator.
Does it matter in what order, like, how come the area of the triangle is one big rad house?
You can. I'm going to take the square root in a second. So I have that, and then I'm going to take my square root. I use 17/5 in my calculator. So second square root, second answer. I just like that feature of this calculator. Push enter. So I'm getting about, I don't know, 57, whatever unit this would happen to be. Area is approximately 57 units square, whatever happened to, I didn't specify a unit, so just units square. So that right there is Heron's formula, used really nicely when solving the area of a triangle given any three sides.